Hello guys, welcome back to John's workshop. In this video and in the 2 or 3 videos that come after it, and I'm not sure how many there'll be in total, this will be the project to make some of the Dickson cartridges for the lathe tool post. So that's what we're going to be doing for the next 2 or 3 videos. So I'm going to bring you in and just show you the cartridges that I've got actually in place on the tool post and the issues that I've got with the ones that came with the lathe, and then we'll move to the bench and I'll show you a bit about how I've done some of the measurement, and then what I'm going to do at that point, and apologies for those who don't like maths, but I'm going to go into almost teacher mode, and I've had to teach myself, to be honest, but what I really want to do in this episode is not everybody has CAD, not everybody has experience of using CAD. You know, there are people who might want to do a project like this who don't have CAD and have got no interest in getting CAD and understanding how to use it, but might want to make something like this by old-fashioned methods, which unfortunately involves quite a bit of mathematics because of some reasonably complex geometry, certainly in terms of mathematically complex geometry anyway. So what I've done is I've had to dust off my very rusty mathematics, because I've not had to do stuff like this for a good 20 plus years. So I'll take you through how I've worked out the angles and everything like that to give myself the dimensions that I need to work to when I'm machining, and I'll take you through how I plan to machine the holders, in what order, where I'm taking my datums from, and how I'm planning out the tool holder machining element of it. So I'll bring you back in at the tool post and we'll crack on looking at the detail. So you can see there, this is the tool post. This is in good condition. This is an original Dickson, so it's good quality. As I showed in a previous video, I've stripped and cleaned and rebuilt this, so I'm happy with the state it's in. I got 3 of the cartridges with the lathe. 2 of them are original. I think, you know, I'm fairly sure they're Dickson, but I'm not. I can't be convinced, but they're definitely original ones. And one of them is an Asian, I'm guessing Chinese import one. And what I've had to do in terms of what I'm doing now is go through all 3 of them and find the best ones to take measurements from. But what you'll find out of all 3, if I put these on, so this is one of the original ones, if I actually load it to the tool post and I'm pressing on hard there, I don't know if you can hear that, but there's about 4 or 5 thou lateral movement there on the dovetails on that one, and that's one of the original Dicksons. On this Chinese or Asian import one, I can't be exactly sure, it could even be Indian import, don't know where it's come from. You drop that on, there's probably, yeah, it just moves in all kinds of directions. It just doesn't sit nicely on there at all. So I've taken no dimensions off that one at all. What I've done is use these 2, this one and the 3rd one that I'll show you, which is the best one. When I put that 3rd one on here, there is absolutely no play at all, so that's the one that I've used to take the majority of my dimensions from. So we'll move to the bench now. I'll show you some of that, and then we'll get on with the maths lesson. For those that don't want the maths lesson and would rather just go to CAD and rather see just swarf being made, then please skip this bit, apologies, but I'm hoping somebody else might find it useful. Okay guys, we're at the bench, so I'll just take you through what I've been looking at and what I've been sort of manhandling and measuring and thinking about. So you can see here the 3 Dickson holders that I've got, well, 2 Dickson and 1 import. The import one I'm just going to take out of the frame, it's rubbish, so we'll just get rid of that. Of the other 2, these are the ones that I've measured, and this one here that you'll see on that I'm holding up now is the best one of the 3. And you know, there's some key dimensions on these things, and I'll talk through those in a moment, but I just thought I'd show you this, how I've taken some measurements of the key dimensions, and then when we move to the whiteboard, hopefully it will make a bit more sense when I start showing you some of the dimensions that I've got. So I've used some drill rod here, so it's ground drill rod, you know, very good cylindrically ground rod, very accurate. That's been clamped into the dovetails or into the V's, and I've been taking measurements both height wise across the pin and also across both pins this way at both sides, you know, each end, and taking average dimensions, and I've done that just purely on this block because this block fits really well to the tool post. The other block, which is an original Dickson, what I've been using this block in conjunction with this one is to take the average dimensions of some of the, you know, the dimensions that don't really matter too much, then they're not critical, so like the overall height, the overall sort of depth, you know, I've been taking kind of an average over both blocks because they're both in various states of condition. And the good one here, unfortunately, on the inside of here where the pullback action happens, is all kind of mashed up, so it's quite difficult to get some good measurements. So again, I've taken most of that sort of inside measurement off this other original Dickson. So between the two, that's what I've been doing. These are sort of the weapons of torture that I've been using to get my dimensions. So some vernier measurements, you know, for the sort of inside dimensions. These are all quite rough, they don't need to be accurate, they're just clearance largely. And then 0 to 1, 1 to 2 and 2 to 3 micrometers, all imperial, because that's, you know, all my measurement gear is imperial because it's that old. And that's what I've been using to measure up all the other dimensions on the blocks. So what I'm going to do now is reposition the camera up on the whiteboard, and I'll take you through basically my planning, my datuming strategy, what I'm thinking of order of operations, and also how I've got to the dimensions that I've got to. So apologies in advance, this is going to be a bit of a math lesson, and it's certainly been one for me, but I have, what I did do, you know, this has taken me 2 or 3 hours I think in total, scratching my head and drawing many triangles, trying to work out how to get to the sort of dimensions that I need. What I did do was I also once I'd finished, I threw this into CAD, which actually took about 3 minutes, and I just double checked my dimensions in CAD to make sure, because what I don't want to do is put this out and then somebody say you made a mistake with your maths. So I'm fairly sure that the maths that I've done is correct, so hopefully this will help somebody else. So we're at the whiteboard, guys. Apologies for the flicker, please bear with me. It's going to be particularly bad while I'm doing this, so you know, I do apologise for that, but hopefully you'll still be able to see what I'm talking about. I'm going to try and make this as painless as I can. So basically what I've done here is I've drawn out the Dickson tool holder. There's some dimensions that I have taken. So firstly, the key at the top, green is datums, blue is dimensions, red is supplementary geometry, and black is just geometry. So the black outliner obviously is the Dickson tool holder in sort of plan view looking down from the top, and there's a load of dimensions struck around that. What you'll also see in terms of datums, whenever you're making something like this, you need to decide where your datums are going to be. So I've made a decision that I'm going to make datum A and datum B. So this bottom left hand corner is basically going to be my master datum. I've got a centre line which will become a datum, mainly for the positioning of the holes more than anything. And then what you'll see additional to all of this is there's an additional hole here that's not in the shop bought or the existing holders, and I'll come on to why that's going in there in a minute, but that's going to be almost a transfer of datums, if you like, a local datum that will be put in reference to this bottom corner, but will be used to govern this right hand side dovetail geometry. I'm calling it dovetail, it's not dovetail, but the 90 degree geometry in this corner, the actual location. So you'll see there's a whole load of geometry on there, and I don't intend to go through all of those dimensions because most of them have been taken off just straight off the micrometers, as I've already said. The 2.44 dimension is what I've taken by measuring across the two bits of drill rod, as I've just shown you, and then taking off a full diameter of one of those drill rods to get me to the centre point, so I know exactly where the centre of the V's are on the good holder. The red supplementary geometry is just showing which diameter pin that I've used or drill rod that I've used to take that dimension, and that's important because I've also measured down off the top of that down back to my datum face A, and that will become more important as we move down into all of this stuff down here, which will take a bit of explanation. So the reason I'm going to put this additional hole in here is because I need a way of governing putting the first slot in place, so putting this first sort of location surfaces, the 90-degree surfaces in place with respect to my datum A and datum B corner. Now when this is in the vise, there's absolutely no way that I could measure from that corner to either any of these faces. It's not going to be accurate. Once I've blocked out this rough shape, I'm going to be filing the edges, so this won't be a sharp corner, it'll be a filed edge, so you can't take any dimensions from it literally. So, but what I can do is touch off this edge, get an accurate X and Y datum, and then I can put this hole in with respect to that. This hole is going to be a 5mm reamed hole, and I've got a reamer ready for that, and I've also got some 5mm drill rod, which will be an incredibly good fit in that hole once I've put it in. So what I shall then do is I shall come off this, using this as almost a dowel pin sticking out of the hole. I'm going to come off that pin and reference where this face needs to be and where this face needs to be with reference to that pin. So I've got something to work to while the units are in the vise. So what I'll do now is move, the only other thing worth noting on here, you'll see a lot of the dimensions are just general dimensions with no tolerances. Some of them I've gone to the effort of putting tolerances against, plus or minus 1 thou, plus or minus 1 thou, and those are all the dimensions that are linked to transferring this datum from this corner to this dowel, and then across from this location edge back to this location, which will be machined secondary. So the first side I will do will be this side, and then I'll machine the second side in with reference to that, measuring across the pins as I've just shown. So getting on to the more difficult stuff, what I don't intend to do is go into doing all these calculations. You can follow this along, you can check the calculations out yourself. I'm not going to stand here and punch numbers into a calculator or anything like that, but I'm just going to talk you through how I've arrived at the numbers. So the two key critical dimensions that I needed to find were from the edge of this pin in a parallel line to this face. So I've got a drop from this face to the outer edge of this pin, and similarly from this face to the pin. So if I extended this face here down, there again there'll be a dimension back to the pin. And I've called those two dimensions X1 and X2 just so that we know what we're talking about. So where I started with this was I picked a nominal position, which I've picked as 0.790, and that is just purely nominal, and how I derived that was by looking at the block and seeing where I could put the hole in, where it wasn't going to be dropping through into the tool sort of groove or one side or interfering with any other geometry. So that is just a nominal value that I've chosen, and I've also made an assumption that the centre line of this secondary datum pin will fall coincident with the transition between the angle there and the top face, and that is just a decision that I made. It looked a decent place to put it, so I made that decision to make the maths easier. So I started off drawing a triangle from that corner there to the centre of this hole, out and then up at 45 degrees, which is the angle of the location face, which is basically this triangle here. And I know the distance from the centre of the hole to the top edge because I can calculate that by taking away my 790 from the overall height, which is 1.227, which leaves me with 0.437. Because the angle is 45 degrees, I know the base of that triangle is also 0.437, and here's x1 that I spoke about, which is the distance from the pin to that edge. So to derive x1, I just need to multiply that number by the cosine of 45 degrees. So x1 was quite easy to find. x2, which is if I extend the other 45 degree line downwards, was a bit more difficult to find, and that's all of this red stuff, so apologies for that, but I'll take you through that now. So the first thing I needed to do, I've measured off the top of this pin down, so I know what that height is, and the distance that I really needed to find here was the distance from the centre of that pin down to the bottom of this groove here. So the easy way to find that, I've drawn that there, so you can see the pin locating in the 90 degree V, and basically you construct some triangles out of that. This pin will sit tangent to these two faces, so we know that these two corners are 90 degrees because it's tangent. So basically I've created two triangles here, and they're congruent triangles, which basically means they're mirror images of each other. So everything that's on one side will be in the reverse on the other side. I've given these corners some names, so we've got ABC. So angle BAC, which is this angle at the bottom, we know that's 90 degrees because that comes from the geometry. Half of that will be 45 degrees, so angle BAO, which is there to there, so 45 degrees. We know the radius of the ball. It's a 5mm ball in this case that I've used. So no, sorry, 6mm ball. Apologies. It's a 6mm dowel. So the radius is 0.118. That's correct. Therefore, AO, which is this centre line here up to the centre of the pin down to the transition, is the radius, which is 0.118 divided by the cosine of 45 degrees. So then what I needed to do, so that gets me AO. I then need to add the radius on again to get to the top of the dowel, which is where I've measured from the top of the pin down to the bottom of the block. So I add on the radius to that, and that gets me 0.2848, which is the number in this box over here. If I then take 0.2848 away from 1.218, which is the distance I measured from the bottom of the block to the top of the pin, so I'm effectively going to take that distance away from it, I'll then get the distance from the bottom of that transition to the bottom of the block, which is 0.9332. If I then take away from 0.9332 my 0.790, I then get the distance from the transition corner here to the nominal number that I've got to where I'm going to place the secondary datum. That gives me a number of 0.1432, which I've called L1, and you'll see why I've called it L1 in a moment. So then we move down here to this lower set of geometry that I've drawn, and you'll see that I've created a triangle here at the bottom where half of that triangle's base length is L1 and the whole of that triangle's base length is L2. And because I've calculated L1, L2, because we're working with 45 degrees, it's just double. So L2 is double L1, so that's the L2 dimension there, 0.2865. So I now know the bottom of that triangle length. And then 0.437, so if you go back to my original triangle here, where we calculated x1, that original triangle sits here. So you can see that sort of triangle there. And we know that the base length of that original triangle is 0.437. So if I take L2 away from that, that leaves me with 0.1505. At this point, I've now created another triangle, which is here, and apologies, this is getting very small, but where one of the legs of that triangle here is my x2 dimension, which is where I need to get from this dowel to the extended angle that comes in from the location angle. So basically, to find x2, which I've called this dimension here, I need the top of that triangle, which is the L2 dimension, times by the sine of 45 degrees, which is the angle, and that gives me a number of 0.1064. So my x2 dimension is 0.1064 and my x1 dimension is 0.3090. So I now know the distance from the centre of that dowel pin to that face, and I know the distance from the centre of the dowel pin to the theoretical face if I extended that other angle downwards. And from that centre point I can add on the radius of the pin, and I can then set my cutting tool to the right position to machine that first location end in. Once that's been machined, I can then start machining the second one in at this side, and I can measure across the pins this way to make sure I get the length right, and I can measure from the top of the pin down to the datum face A of the block to make sure I get the height right. So apologies for that, I hope you followed that, and I do feel like I've rushed through that, considering it's taken me about 3 hours to get to that point long-handed. If anybody's got any questions on that, on how I've derived it, please shout up. I hope you've managed to follow along that. One thing I will say is the good old Zeus book. You know, I used to use this a lot for trigonometry. Once I got really good at it, I didn't need this anymore, to be honest, but that was 25 years ago. All of these triangles that I've drawn to gather my dimensions, they're all right angle triangles, fortunately, because I'm working with 45 and 90 degrees, so they're predominantly all right angle triangles. If you go to the very back page in the Zeus book, there's a whole page there of right angle triangles, and it tells you, it shows you which data you've got, which data you're looking for, and what the equations are that you need to plug in to get the answers. And that's what I've used to help me through this maths down here. So it's dead simple maths, really. It looks complicated, it actually isn't, and I hope for anybody that's not using CAD or doesn't want to use CAD that's been helpful. For those of you that want to use CAD, I did stick this into CAD. It took me about 2 or 3 minutes, and I did actually verify my x1 and x2 dimensions that they were correct, and they came out spot on. So I'm happy with the maths. There may be an easier way than this, and I'm sure some boffin mathematician would have drawn 50 triangles less than me to get to the same answer, but at the end of the day the answer's correct. So in my mind it doesn't matter how you get there, as long as you get there correctly and you verify that what you've got is right, which is what I've done there. So without further ado, the next thing I'm going to do is start unpacking the O1 steel that I've got, and we'll cut a section of that off, and I'll take you through the planning of that section, because I've got a big long piece and I'm going to be machining that in sections, and I'll take you through the planning and thinking behind how many of these I'm going to machine at once. I'm going to try and machine multiple cartridges at once to make life a bit easier, so I'll take you through that thinking and how I've got to that point. So I do hope that was helpful. Right, what I've done there, guys, I've got rid of all the scary stuff at the bottom. Basically I've taken a note of my x1 and x2 dimensions, which were what all that was all about, and I've replaced all of the trig and everything at the bottom with a view of the tool holder tipped through 90 degrees, so you can see the other key dimensions. I need those because obviously the first thing I'm going to be doing is blocking these out to rough overall sizes. So 1.738 is key, 2.880 is key, which is the overall length, and then the third dimension that's key is 1.227. So those are the three dimensions that I'm going to start off with. And what I've got here is, so I've got a length of ground flat stock that's very near sort of overall sizes. There's a bit of material to come off everywhere I think on this. I'll measure it up and check, but there's enough here to make 10. Now, ground flat stock, it's otherwise known as O1 steel. It is tool steel. It's what's used for making knives, press brake, guillotine blades, things like that. It's got the potential to be incredibly hard. If you think of the fly cutter that the video's already gone up on that I've made, the actual tool steel that's in there, it's the same steel. So other than the tool steel's in a hardened condition and this is in a relatively soft state. So what I'm going to do next is calculate roughly how many I'm going to make. I think the original cut-off is going to be to make 4 off that length of 10. So I'm going to make 4, and what I shall do to start with is block the overall dimensions out as we've just discussed. And firstly I'm going to just put in the T-slot area, if you like, in the back edge across all 4 of them. And then I'm going to turn it through 90 degrees and I'm going to mill in the 4 slots, because I want to get any movement, any stress relief, any material movement out of the way, and by taking these 4 slots out and by taking this area out, that's going to allow it to relax and move. At that point I'm going to cut that block in half, so I've got 2 lots of 2, and then I shall be setting them up in the vise, and the restriction there is the amount that my vise is going to open. We'll set them up in the vise and then we'll start machining the the accurate stuff in sets of 2, and once I've got the locations cut I shall then chop those in half so they become individual items, and then we'll finish off the other dimensions at that point. So that's roughly the plan, the order of machining. So the first thing I'm going to do is get the ground flat stock unwrapped, get it marked out, get it in a bandsaw and start chopping lumps off ready for milling. So there's the first section being chopped off the ground flat stock. There's enough to get four holders out of that section that's been cut off just there. So I'll bring you back when we've got that cut off and we're at the milling machine setting up for the blocking out. Right guys, we're at the mill. We've got the first section cut off. I've just run a file over the ends just to make sure there's no sharp edges. It's more about cutting my hands than anything, because they're not going to be in the area where we're locating in the vise. With this ground flat stock, the clue's in the name. It is ground flat and they guarantee it this way to be flat. All the other faces, so these faces and the end faces, are just rough machined and they're not guaranteed to be square to the ground flat faces at all. They're just machined. They're normally pretty good, to be honest, but they are quite a rough machine finish. So the first thing I'm going to do, because I know these two faces are absolutely parallel to one another, we're going to hold it this way up in the vise the way it is just now, and we're going to machine the first face on the top so that we know then that is square to the two ground faces, and then we'll turn it the other way up and we'll finish it to the blocked out sizes. So what I'm going to do for this first cut, I've just got a piece of drill rod there. I'm just going to drop a piece of drill rod in the bottom of the vise, and what that means is then I've only got line contact on the bottom face, so there's no influence at all from any outer squareness that there might be. So we'll drop it on that drill rod, and you can see there, because it's set on the drill rod, you can just see it's articulating completely, so it will just take up the fixed jaw position on the vise, no problem. So we'll just clamp this up. You'll see I've got my the clamps that I made in an earlier video now holding the vise down. I have filmed a bit of video about the vice modification. I'll put that up in a separate episode if it's not already been up. So we'll just give that a nip. And then we're going to have a go with the fly cutter. So this is one that I made in an earlier video. What I've got now is the grub screws have turned up, so they're 3 M8 stainless grub screws, and I've also ground the cutting edge, so I put a new cutting edge on, and I've stoned a nice radius on the corner. What I don't know is whether I need to put any clearance relief on this back edge, and I won't know that until I've put it in the spindle and just looked at it over the workpiece. I may need to put a tiny bit of clearance on that underside, so we'll set that up in the mill and we'll have a look. Just have a look at that now. No, that's as I suspected. It's got its own clearance, which is how I designed the fly cutter. So really the only grinding I ever need to do on that is what I've done there, which is keen the front edge up and then just lightly stone the radius, depending on what size radius I need. So this is actually a bit too big for it this way round, but we'll leave it at that setting. What I'm going to do, and what you'll see, is I'm going to set the fly cutter in the y-axis to just past the radius, so that way it's in cut a lot longer. It's got a lot more engagement in the cut, and it's not breaking. If you put this on centre line, you're almost hammering both sides of the each time the tool comes around, it's hammering both sides of the stock. Whereas if you set it like that to just past the radius, you've got to hammer on at one side, but then it stays in the stock all the way around, and it just saves a lot of sort of backwards and forwards forces into the machine. So we'll set that off at there. I'll knock the y-axis off. Now we need to go pretty steady with this. As I said earlier, this material is exactly the same as this material, except this is in a hardened and tempered state, so they're very similar in hardness. So this needs to be running reasonably slowly. So I'll just have a look at my speed selection. We'll probably go for 280 to start with. We'll see what that looks like. So it's in a low range, high speed. We'll start with that and see how whether it's going to work or not. I'm just going to look at my dimensions. We're 2.880, and I know this is 3 inches across it, so we've got 0.120, so 120 thou to come off, so there's plenty of stock on there. So we'll probably go for something like a 10 thou cut on this side and just see how it performs. I don't want to go too mad with this cutter until I've got some confidence in it. We'll give it some assistance. It's looking good, guys. I just wanted to check the cutting edge, make sure it was holding up, but it looks very good. So I'll bring you back when we've got. It's not the fastest thing in the world, so I'll bring you back when we get to the end of the cut.